for each picture, I'd like you in your groups to decide what the force diagram is. So for the book sitting on the table, let's just talk about it when you've all had a go.
Using pictures is one way of providing a variety of contexts to help students model different scenarios in terms of the formal representations, which they will use to help analyse and solve problems in mechanics.
Once they get to the pure mathematics of the problem, they're fine, they're happy, but getting there they find really difficult. As a teacher, you're thinking, well, how do I approach this? Do I go right back to basics and do something like we did today, where you're just producing the diagram, or do you try and shortcut? And often in shortcutting, you're actually not fixing the problem, I think. So I think it was very useful today, actually. Well, you haven't all drawn the same thing as each other, have you? Because look.
Allowing time for this helps reveal students' thinking and provides opportunity to explore their ideas with them.
So they're using a different approach in terms of their drawing. What's different?
Mike's assumed it's a particle.
Okay, Mike's assumed it's a particle, whereas Tom's kind of preserved the dimensions of the book. Does it matter?
Not
for us.
Not for you?
No.
Might it matter?
The resulting discussion helps identify difficulties in understanding and also helps resolve areas of confusion.
I had an interesting one where they were modelling a book on a table. Some of them were using a particle, and some of them were drawing a kind of a rectangle to represent the book. And we had a discussion about whether it would ever make any difference. I said, can you think of any situations where it would make a difference if you were to kind of reduce the book to a particle? In what situations might it matter? Are there any?
Friction. When you're trying to figure out the friction of the book on the table, and air resistance and all that, the shape would matter.
Would it?
Yeah, because it would have more friction if it was a bigger surface than if it was a smaller one.
So what does friction depend on? Let's have a look at three more, I think. Mechanics problems at this level really kind of fall into two categories. You've either got a horizontal surface or an oblique surface. The photos were a mixture of both. There was one problem where there was a connector system, which again is quite a common scenario within the mechanics A-level. So I wanted to look at a range of different scenarios.
So for the car, you've got the driving force acting forwards, and then you've got the tension from the trailer. I'm guessing it's a rope or something in there. And you've also got air resistance, and then you've got gravity acting down, and the natural reaction from the road.
When you say air resistance?
Or resistance. Friction as well.
Friction as well.
If the swimmer's going to be swimming on the water, it's going to have some sort of reaction force, which is provided by the upthrust of the water, I assume. And then if it's moving at constant velocity, which I'm assuming, if it's moving in that direction, it's going to have a resistive force in the other direction. Basically the same for the plane, except you replace upthrust with lift.
And then the trailer?
So you've got just tension forward because there's no actual force coming from the trailer.
In choosing the contexts, the teacher has included scenarios which to the students may seem initially more challenging than they might usually encounter.
How do you draw a swimmer?
I know, I was
draw a dot.
I think they're much more willing to take a chance with whiteboards as well.
Yeah.
They don't mind being wrong so much when it has this kind of lack of permanence.
How then to take things forward?
Actually producing the diagram wasn't the problem, it was then looking at how you get from that diagram to the equations that are going to enable you to solve it using pure mathematics. But I think this is a big part of the process, and I think a lot of them will come out of this experience thinking, actually, if I can get that diagram right, I'm well on the road to being able to unpick the problem.